Hi, this is Amin, and in this video, I'm going to give you an introduction to 5G. After covering a lot of videos on LTE systems, on attached procedure, on tracking area update, voice over LTE, voice over Wi-Fi, circuit switch fallback, IMS, and all of them LTE security. Now it is a time to have an introduction on 4G and see the configurations. Architecture inside the core. So we know that based on whatever we've learned so far, the first release of 4G or LTE was release 8, and it came till release 14, which was the preliminary study of 5G. And the release 15 was the first phase of that, which was in the year 2019 till now. So let's see at all of the concepts one by one. In the past, when people talked about connection to the internet, and speaking of connectivity, people just they talked or they think of the connection of their laptop to the internet or their cell phone to the internet, and not more. But now, due to massive MIMO, new technologies, many evolution on the network connectivities, and also IoT, we can think of that more and more. So we can categorize them in EMBB. So we can think of them handsets, applications, and autonomous vehicles, and also sensors. We can think of massive machine type communications. For example, imagine there is a telemetry system. I don't know, for maybe import or export of gas or oil inter country, and the telemetry station, which is located in a remote place. So there's a central office to monitor whatsoever, the elements of the gas or maybe oil or water, temperature, flow, pressure, and the operators are there to watch them online without any latency or something like that. So what do we need? We need some sort of sensors at a remote place to sensing, measuring all of the data and communicating them as fast as possible to the center in order to have better understanding about what is going on that remote place. So now we can think of these more and more. Now we can think of many services. If we want to categorize them, we can think of MMTC, URLLC, and EMBB, or we can think of them in this way: human-to-human communication, for example, talking to someone, human-to-machine, or machine-to-machine, like sensors, or doing some sort of surgeries with some devices. And these are important scenarios. Now, maybe you are at a vacation and you want to see what is going on at your office, at your home, at your farm. So all of the CCTVs, they have a controller and they are connected to the internet for all of the remote sensing or remote controllings. We have a cloud in our system, our for usage, which are ultra reliable, and it is very important, and low latency, like police, like fire department, like all of the surgeries, also our watches, smart watches. Everything. Now we can think of everything as a service which is available to us. On this slide, I just come up with some sort of differences in 4G, or I would say advances in 5G. It is better to paraphrase that. For example, latency in LTE was 10 milliseconds, which is here now in 1 millisecond. Or mobility, or everything has evolved, everything. And we can see the differences here. And if you want to take a look at the RAN architecture of both of them, we knew that on LTE, InADBs were connected to each other by means of interface X2, and all of them were connected to the MME by S1. So we had S1U and S1 MME, one of them for user data or user plane, and the other one S1 MME for controlling stuff or for the signalings. The basic architecture of both of them are the same, but the interfaces were changed. We have XN or NGCU, And also, there is no MME or SGW. So in 5G new radio system, we have different interfaces. We're gonna take a look at all of them. We're gonna talk about them. Just this is an overview for you. So instead of E not B, what do we have? We have G not B and also NG E not B. NG not B is next generation E not B for the scenarios that you is capable of a connection or capable of connecting to both 4G and 5G systems. In 5G, we are talking about NG RAN or next generation RAN, or we call it 5G NR, new radio. GNLB is just for the 5G system, but NGNLB can provide UTRA, EUTRA, or we know about that is for 5G connection, for 4G connection, and also the XN interfaces for connection between them. So far we know some sort of differences. Let's continue. Here we can see we just want to focus on 5G radio network. So what do we have? We have AMF, UPF. We will talk about them, but they are connected. All of them. I mean, the interconnectivity is okay. All of them are here. But inside one GNLB, what do we have? We have central unit and we have distribution unit. So with splitting them into two, the GNLB will know exactly the intention of the UE while a subscriber is using the data. And we're not going to talk about F1 or X and C, but anyway, we will know about that each GNLB has two functions or two units for allocating a service or for the communication to a center, to a core. Let's call it core, not center. They are central unit. At first, let me tell you, both of them are logical nodes, but central unit for transferring the data, mobility control, radio access, network sharing, positioning, and all of this. But distribution or distributed unit, it depends on the function that you want to use. So the other difference is, which is just at 5G, I mean, neither LTE nor UMTS nor Edge nor GSM, OFDM now is a scalable, which will enable us to do what? To have millimeter wave, indoor wideband, to have better bandwidth, to have faster communication, and so on. So a scalable OFDM that we can scale our bandwidth, we can scale whatever we want to use, it will help us to have better throughput on our system. And then we have beamforming, more powerful. If you want to take a look at that, we have to see this slide. So here, imagine this is 4G, and there is a coverage of one INAD, and maybe, I don't know, this one is using the best beam, not all of them, but here, due to 5G, we can consider this scenario. So all of them are using a good beam, all of them are using a good service due to beamforming or massive MIMO, which is very, very good in order to have a better coverage and good bandwidth to our system. The other difference is network slicing. So in 5G, we're gonna slice our networks, and based on the usage. For example, there is a user which he or she just wants to have IMS calling. So he or she just wants to make a phone call, and the data, I mean, based on the service that you want to use, the RAN will see, okay, just a call, and let's allocate this slice to the user. Or maybe this is the IoT device, and based on the usage, the GNAT will say, okay, you're going to use, I don't know, some sort of measuring, so maybe the bandwidth is not high, but the communication should be reliable, should be fast, the latency now is a matter for you, this slice is for you. And with that kind of categorizing the slices, with that kind of slicing them, we can have a better, much better system in comparison to the LTE. So after that, we are saying that 5G has a big bandwidth, it is perfect, but how? If you can remember, In 4G, we have a frame like this. And look, frame duration in both of them, I mean either 4G or 5G, is 10 milliseconds. And subframe duration also is the same. So based on that, we can say in LTE, this thing that I'm painting is LTE. I'm sorry, my painting is not good. This is a frame of LTE, so let's call that LTE. This frame of LTE, it is consist of 10 subframes. A frame is 10 milliseconds and each subframe is 1 millisecond. So a frame of LTE consists of 10 subframes, and each subframes were splitted or divided into 2 slots, and each slot has 4 symbols. But here, each subframe, at the first change, each subframe has 14 symbols. In LTE, each subframe has 7 symbols. Each slot in LTE has 7 symbols, while in the 5G, each slot has 14 symbols, and also it is scalable. Look, it was fixed. In LTE, each subframe was divided just into 2 slots. But here we can see, based on the frequency and bandwidth that we are using, so each subframe can have different number of slots. And in this way, so as long as the slot symbols are the same, we can achieve more bandwidth and better service. So the last thing I'm going to talk about is the waveform, which is changed. We know that always downlink in the mobile technology systems, downlink is a matter. Uplink. Downlink is not a matter, because downlink, it means communication from base station towards a UE. Whatever station, BTS or not B, E not B, G not B, because the base station is using AC power of the city. So the AC power is strong, and the base station can achieve whatever power it wants. So it can broadcast with a good power. But having a big or powerful power amplifier in a UE, it is something which is not achievable, the first thing. The second thing, if a UE wants to have a good power, so many battery usage will be the result. So on LTE, what did we have? We have OFDMA for the downlink and SCDFMA for the uplink, and the power was a matter. Power still is a matter, but now the uplink scenarios change. CPOFDM and DFT, discrete for transform OFDM. So this one is changed, and the UEs which can use or which can connect to the 5G system, so they can have better thing for the better bandwidth or better communication without using lots of power to their station. And also they have OFDM and NOFDM and NOMA. We have non-orthogonal multiple access and the coding scenarios. So this is the first overview and introduction to our 5G system. In the next video, I'm going to talk about the core and the functions which are located inside the core. If you enjoyed the video, if you like that, show a thumbs up, hit on the like button. If not, thanks for watching the video. Don't forget to subscribe to the channel, and bye everyone.